Hello everyone, this is Dr. Marrero from Math Topics. If this is your first time, thank you for watching. Finding the minimum value of the function. This is today's video. At the end, when you finish all the recording, if you want more questions about this, go to the description box and click the link for interactive learning. So you will have access to a website in which I'm gonna put examples, not only for this video, for many other videos, if you wanna practice those videos. Don't forget to share. Finding the minimum value of the function. Today, we have a function which is a quadratic function, f of x equal x squared minus 8x plus 15. You can see it right there on the board. And to find the minimum, I want to discuss two perspectives. Let's say that you are an Algebra I student and you don't know anything about calculus. So we are assuming that. So we are going to answer from the algebra perspective, and then we are going to solve it from the calculus perspective. And this is a way to integrate mathematics and to learn mathematics. How can we find the minimum value? First, we have to know the graphing perspective of a quadratic equation, a quadratic function. So keep in mind that this is more or less a quadratic function, okay? It's a parabola. And we have many features on this, but we are not going to talk about the feature of the parabola right now. We are going to talk about the minimum, and we are going to talk about the vertex of the parabola and the opening of the parabola. You notice here that the parabola has a minimum value here. So that's the minimum value, and it's important to know that the minimum value is not x value, it's y, it's a y value. The same way, if you have a parabola right here that is opening downward, this is the maximum. So we have a maximum here and we have a minimum here. This is important visualization of the graphing perspective of this algebraic question. So finding the minimum. So the parabola, we have those two combinations, functions. We can have a minimum and we can have a maximum, okay? Also, the parabola has, let me put it over here. The parabola also has an axis of symmetry. Let's say this is the axis of symmetry that divide the parabola in two equal branches, symmetrical branches. And when we teach this, it's recommendable to say why we have symmetry here. It's because we are working with exponent 2, no? And as soon as we work with exponent 2, imagine that instead of having this, we have f of x equal x squared to see it better. So you know that if you pick a value x, let's say 5, and you evaluate the function for 5, you get 25, 5 squared. But it's also, if you evaluate the function for -5, you get -5 to the power of 2, which is 25. So we have one input that is connected with two different inputs connected with the same output. It's still a function. This is important when we talk about words in mathematics, in teaching mathematics. We need to support the vocabulary. And to support the vocabulary, give us what I call rigor in our teaching and rigor in our learning impact. So why we have an axis of symmetry, and what, of course, visually is dividing, that vertical line is dividing the parabola into equal branches. But what is the reason? What is the algebra behind that? The algebra behind that, and the best way to explain it is using the parent function, which is x squared. And we have x equal 5 and x equal -5, two different inputs that the output is the same, 25. So this is important to understand the entire learning set. If you are interested in learning set, visit our channels. I have videos about what I call a learning set. So in the learning set of finding the minimum or finding the maximum, this is what you need to know. You need to know that we have a minimum when the parabola is open upward. We have a maximum when the parabola is open downward. We have an axis of symmetry. And we have a point right here that is called the vertex. This is super important. So the point there is called the vertex, and the notation is x comma f of x. This is the graphing perspective. This is the playground in which we are going to work this question. Let's see now how can we find the minimum, the procedure, from the algebra perspective, knowing now the graphing perspective. Let's see it. Now we are going to use the algebra procedure to find the minimum. We need an important element, the axis of symmetry, that vertical line, because by logic, by the visualization that we discussed earlier, so if we have here the axis of symmetry, we notice that the axis of symmetry intersect the parabola, intersect the quadratic function right here where the minimum is. So if I can know that axis of symmetry equation, x equal, because it's a vertical line, is 50% of the gain. So let's find it. Number one, it's important to understand that in a quadratic function, the standard form, which is this one, can be written as ax squared plus bx plus c. So a, b, and c. A and b are the coefficient of the x's, and c is the constant. Why I'm saying this? Because for my parabola here, a is 1, b is -8, just to review, and c is 15. Because the axis of symmetry here, okay, is a formula, is x equal minus b over 2a. That's the equation of the axis of symmetry. So it's very easy to find because I can find it by replacing b and a. Since b is -8, I have -8 divided by 2 times a is 1. And basically I have here 8 divided by 2, which is 4. So the axis of symmetry is x equal 4. Very nice. That line here, suppose that is x equal 4. So I already have the x value. And I said earlier that the minimum, the maximum is a y value. So what I do now, I know the input. I know that the axis of symmetry intersect the parabola right there where the minimum is. So I need to evaluate the function for x equal 4. And that's what is next. So I evaluate the function f of 4, which is no more than replacing the x by 4. So we have 4 squared minus 8 times 4 plus 15. So f of 4 is 16 minus 8 times 4, -32, plus 15. So from left to right, this is 16 minus 32 is -16, and -16, plus 15 right here. 16 minus 32 is -16, -16 plus 15 is -1. Boom. The coordinate of the minimum is 4, -1. So the minimum, which is the output, is -1. It's equal -1. So the parabola is a little bit down here, okay? If you want to use this example. This is not the accurate example, but this is the location of the minimum. The location of the minimum is at 4, -1, and the minimum is -1. So the parabola minimum value is -1. This is the algebra perspective. So a standard form, important. Coefficients, important. Axis of symmetry, important. Finding the axis of symmetry will give you that point right there, the coordinate of x of the point, the coordinate x of the minimum, and then you evaluate right here in the function, in the original one, you can evaluate for 4 for your x value, for your input, and the output is your minimum. Simple as that. This is the algebra perspective. How can we do it using calculus? If you're not a calculus student, you can stop the video right here. Take time and see what is next. In calculus, we have something that is called points of inflection. If you want to know how to find point of inflection, check the video from this week. Go to our channel and check the video about point of inflection. What is a point of inflection in the functions? It can be a minimum, can be a maximum. It's basically when the slopes of the tangent lines to the curve, they change the sign in a particular way. So let's say that we have a function. Let me put it over here. I don't know. And we have a point of inflection right here. Okay, that's a point of inflection because the tangent lines to the curves, the slope of them are changing. So notice that the slope on this side here are negative, and after the inflection points, the slope of the tangent lines are positive. So we have something that is negative here and positive here. That's what is called a point of inflection, a possible relative minimum or a relative maximum. This is important. And when we are teachers and we teach algebra, it's important to introduce in earlier years the terminology from calculus, especially high school teachers. So let's say instead of talking only about minimum, maximum, so we can talk about inflections because it's an inflection. So it's a turning point. So we can use turning point, we can use inflection. But if you want to prepare the students for higher rigor in mathematics, we need the teachers, the math teachers. If they don't tell you that, I'm telling you, they need to say, okay, it's a minimum value, it's a turning point, it's an inflection point. Why? Because this is integrating rigor in our teaching practices. How can we find that possible inflection points? We need the first derivative of the function. So the first derivative of f is just 2x minus 8. That's the first derivative function. It's a linear function, 2x minus 8. Remember that we use the power rule here. So you move the 2 to the in front, and you subtract 1 to the exponents, and the derivative of a constant is 0. So we have this. And then we equal our first derivative to 0. So we equal 2x minus 8 equals 0, 2x equal 8, x equal 8 divided by 2, boom, x is equal 4. This is the possible x-coordinate of the point of inflection. Simple as that. And we don't know anything about the graph. That's a point of inflection. So I know that the slopes will be changing the sign over there. The way they change it is the one that's going to determine if we are going to have a maximum or a minimum. Of course, when you have a powerful background in mathematics, you know that this is a parabola, it's opening upward because the coefficient of the x squared is a positive number, so the parabola will be opening upward, and immediately you can say that that point of inflection is a minimum. But in calculus, if you want to know what type of point of inflection, so you use the number line right here, you locate your 4, and you check values in the surrounding of 4. So let's say 0. Okay, let me see my first derivative, which is 2x minus 8, evaluated for 0. So you can have here 2 times 0 minus 8. Notice that my first derivative, when I evaluate it for 0, the answer is negative 8. So we have here negative slopes. And then we're going to pick another value right here next to 4. Let's say pick 5, and you evaluate your first derivative to 5, for 5, and you have 10 minus 8, okay? And 10 minus 8 is 2, so it's positive. So we have negative and positive. So we have an inflection point, so the slopes of the lines are negative and then positive. We have a minimum value at 4. How can we find that minimum value? We simply evaluate 4 into the original function as we did before. 4 to the second power 16 minus 8 times 4, negative 32. 16 minus 32 is negative 16 plus 15 is negative 1. We have the inflection point for negative 1 and the minimum is negative 1. This is calculus integrated. And this is the way that we push high level of teaching and high level of understanding. If you like the video, don't forget to share the video. Give us a like, help Math Topics. Be part of the community on Math Topics. If you are part of the membership, you will have access to more resources, more learning interaction, more private videos. So you are more than welcome if you support Math Topics. Thank you so much. I hope you like it, and I hope that you see the integration between these two. And if you are a teacher, start teaching this way. Not only say minimum, not only say turning point, say inflection points. Prepare the student for calculus. Thank you so much. See you in the next video.